Testing and interoperability, and I have the difficult task of waking you up after the lunch break. Okay, so I'm going to, this session will be about the OSM CI/CD pipeline and the remote labs network, how we are leveraging that network to take the testing further. Okay, this is a high-level overview of the development workflow. There's nothing very special here. It's a very classic development workflow that whoever is developing software must be used to. We're relaying, our tools are we're using Gerrit as code review tool. We're using Git as repository for the source code. We're using Jenkins to automate our testing. Bugzilla to file the bugs and manage the bugs. And we are using also Artifactory to store the artifacts that are built and made available by Jenkins. So just to see how this fits, we are going to make a deep dive into how we are automating the testing with Jenkins to start with. So first of all, you saw the architectural overview by Vanessa. You know now that there are many modules in OSM, and which means that whenever a code change arrives, we might need to build several modules, okay? Which means that we need a multi-pipeline approach for building the code. And this is what we have implemented. This is the pipeline that we follow for code commits. So it's made of 3 stages. First one is just to trigger the multi-pipeline approach. And then we'll see in the next slides what each stage is there for. Okay, the idea is that each code commit is going to trigger this pipeline. Whenever something fails, you get immediate, the developer gets immediate feedback. And if you get to the very end successfully, then your code gets verified by Jenkins, and the module leaders can push it to the main code line. So the first stage, as I was saying, this is triggered by Gerrit whenever a code commit arrives. The idea is to launch the multi-pipeline, multi-module pipelines, and to call stage 2, which will be in charge of building the required modules. We are not going to rebuild everything. We're going to build the modules that have been impacted by this code change. This is a very simple stage. Next one, stage 2, as I was saying, is triggered by stage 1 only on the required modules. It operates within a Docker container, each of them, and actually is going to start as many of these pipelines as impacted modules. Okay, the first step on each pipeline is exactly the same for all modules. It's a scan, it's a license scan, just to verify that the code contribution comes with the appropriate license and that we're still compatible with Apache 2, which is the license used by OSM. Then from here, there are 3 more other steps implemented by callbacks. So each modules need to implement the callback of these steps. First one is to unit test the module. Next one is to build it. And finally is to create the artifacts that are expected out of this module and store them. Okay, for storage, we've been using up to here Artifactory, and we are now moving to Artifactory Pro, thanks to a collaboration with JFrog, which is going to allow us to deal with containers directly. Okay, this is like in the scope of the next release of OSM. Stage 3 is about system integration. We have built some modules, the impacted ones. Now what we need to do is to install the full system. We're going to take the modules that we just built from the previous stage, and the modules that we didn't build because they were not impacted, we're going to take them from Artifactory, from the artifact storage, and we'll take those coming out from the latest successful build. Okay, with all that, we make a full installation of OSM automatically, and we're ready for smoke testing. Okay, this smoke test, we have a battery of tests that are being developed by our teams. They are based on PyTest fixtures. The idea here is to run simple testing that doesn't require access to infrastructure, that doesn't require anything else but what we have in this build environment. Okay, so we're going to do some API checks. We are going to do upload of descriptors, and for that we are leveraging the OSM client library that Gerardo showed in the previous session. And we can also extend this basic testing by using a Vim emulator that we mentioned this morning as well. It's some contribution that we got from academia. It allows to emulate a multi-pod OpenStack deployment. Okay, so it allows to take the testing, this smoke testing, a bit further. Once we've done this, if nothing has failed, we can consider the code verified, and we can accept this code contribution. Okay, so with all this testing, we haven't really tested OSM functionality end-to-end. We haven't tested that the end-to-end functionality is still there, and it's not broken by this code submission. Okay, so something we are doing is to add a stage 4 step in this pipeline that we only call is time-consuming and resource-consuming, so we only call it whenever the patch set is ready for merging the main code line. And actually, the challenge here is to run some system testing, some end-to-end testing with OSM, okay, to verify that the end-to-end functionality is still there. This is triggered, as I was saying, whenever the module leads decide to submit a code set patch to the mainstream. The challenge here is that we've said that OSM aims for interoperability and to be interoperable with many kind of VIMs, many kind of SDN controllers, many kind of infrastructure. So one of this OSM strength is also bringing us a challenge for system testing, okay? Because it means, first of all, that we need access to this infrastructure to run the testing. And secondly, that there are a high number of possible combinations of infrastructure, VIMs, SDN controllers, VNFs, that we should be testing to make sure that we haven't broken anything. And actually, this challenge is something we can solve thanks to another strength of OSM, which is having this large and diverse community. Okay? So the idea here is that we are going to leverage our very modest lab running OSM at ETSI, and the infrastructure, SDN controllers, VIMs, and VNFs that can be made available by the OSM community, okay? And the way we are interconnecting and leveraging these two is using Hive. Hive is the hub for interoperability and validation at ETSI. It's a fancy name for a big router. But the idea here is that we are going to connect our local lab to remote labs made available by the community with the combination of infrastructure, Vim, and SDN of their choice, okay? So initially, we set this up. And we were running manual testing based on OSM client on these remote labs. And the next step was to say, okay, we can do this manually. Why don't we integrate this in the CI/CD pipeline? Okay. So the approach is exactly the same. We had this local lab connected through Hive to these remote labs, many combinations. But we trigger that testing, and we trigger a new bunch of system tests on this remote lab setup, okay? And this is integrated in the pipeline. We can run this as this stage 4, or we can decide to run it as a standalone regular job, eventually daily, nightly, or how we think it's better, okay? So these remote labs, actually, we're finding plenty of uses for them. It's not just to take the system testing of OSM a bit further. It's also allowed to have our OSM community that are providing remote labs participate to the NFV plug test very smoothly, okay? Because for plug test, we set up a very similar approach with another entity of Hive. We are interconnecting participants' labs, and we are making these remote labs available to the plug test participants. So the only thing we needed to do here is to bridge these two Hives and on a case-by-case enable a routing between these OSM remote labs and the plug test environment. Okay? So this is actually what we've done in the 2 last plug tests. I will be talking about plug test on Thursday, if you're interested. And actually, we got a very, very high participation of the OSM community in PlugTest, not only as OSM distributions, but also bringing their VNFs and bringing their infrastructure and testing in that environment, not only with OSM, but also with other orchestrators, other testing partners. These OSM remote labs, we are also using them for Hackfest purposes. How many people here will be joining the OSM Hackfest from tomorrow? Hope some of them are here. Okay, so you are going to be playing with these Hive and OSM remote labs. The idea is that we take exactly the same approach I presented with our local servers at ETSI and the remote labs offered by the community, and we're going to deploy an additional Nomad Hackfest lab. This is being deployed as I talk at Intel, which is our host for this week Hackfest. Okay, so it's going to allow Hackfest participants. It's not just going to be sitting there and listening and watching some PowerPoints. You're actually going to hack it in. You will be bringing either your VNF or testing with some test VNFs. You will be able to run OSM either on your laptop or either on the servers at ETSI. And with any of those approaches, you will be able to orchestrate the remote labs that the OSM community is making available for PlugTest. Okay, so yeah, actually I wanted to take the opportunity now to thank our host for the Hackfest, Intel, and also all the OSM community members that are providing their remote labs, making them available for running this exercise. And also I wanted to thank you as well for your time and for listening.